Hello everyone. In this tutorial, we will demonstrate the process of creating a script and attaching it to a game object within the Unity game engine. If you wish to follow along, it is recommended to review the previous tutorials in this series for optimal understanding. However, you are also welcome to simply sit back, listen, and learn. We'll only briefly touch on general C#. The focus here is Unity-specific C# code. If you already have some basic C# knowledge, you'll do just fine. However, if you're completely new to programming or C#, I recommend checking out a beginner-friendly C# course first. Now, let's dive into C# scripting. We'll create a script and attach it to a game object. Let's start by creating our first script. Go to the project window. To keep things organized, we'll start by creating a folder for our scripts. Right-click in the Assets folder and select Create, then Folder, and name it Scripts. Now select the Scripts folder and right-click in that folder and select Create, then Mono Behavior Script or C# script, depending on which Unity version you use. Rename the script to Player Controller. Double-click the script to open it in Visual Studio or your chosen code editor. Let's break down the code that is generated for us. The top line, using Unity Engine, imports the Unity Engine namespace, which contains the classes and functions we need to interact with Unity's engine. Think of it as unlocking Unity's toolbox for game development. The Player Controller class is derived from Mono Behavior, the foundational class for all scripts in Unity. By extending Mono Behavior, our script can function as a component that can be attached to game objects. The start method is a special Unity function that is called once when the game object is first activated in the scene. It can be used for initialization, such as setting up variables or preparing the game object. For example, if you want to set a starting position or play an intro animation, you'd place that code here. It is only run once, even if the game loops back to this scene. The update method is called once per frame while the script is active. It can be used for anything that needs to be checked or updated constantly, such as player input, movement, or animations. Since it's tied to the frame rate, it runs as often as your game renders frames, for example, 60 times per second on a 60 FPS game. Let's expand the code to showcase these methods. We'll begin by using debug.log, a handy function for sending messages to the console, which is especially useful for testing. In the start method, we'll add the line, debug.log, the player controller script has started. This will confirm that the start method has been activated. Next, in the update method, we'll check if the spacebar is pressed using input.getKeyDown keycode.space. Each time the spacebar is pressed, we'll log a message to the console. This provides a simple way to verify that the input is being detected correctly. Let's save the script and return back to Unity to test our script. Press the play button to start the game. You'll notice that nothing happens yet. This is because while we wrote the script and have it in our project, does not mean it will run. We must assign it to a game object so it can be executed. Stop the game and let's attach the script to a game object. While we could create a new game object in the hierarchy to attach it to, we already have an existing one, the player object, so we'll use that instead. To attach the script, simply select the player object, then click Add Component in the inspector, and type the name of the script to add it. Alternatively, drag the script from the project window to the player game object in the hierarchy, the scene view, or the inspector when the game object is selected. Once attached, the script will be executed during gameplay. Let's test it again by pressing play. As you can see now in the console, the script is actively running, and any messages or outputs we've added, such as debug.log statements, are displayed here. This is an excellent tool for testing and debugging your code during development. You see the message from the start method is displayed when the game begins. Each time we press the spacebar, the message from the update method appears in the console. The console will also show errors if your script has any issues. Let's purposely add an error in the code to demonstrate this. After introducing an error, when we try to start the game, Unity will display an error message explaining the issue. Errors appear in red in the console, making them easy to identify. Additionally, you won't be able to test or play your game until all errors are resolved, ensuring your project remains stable. Debugging through the console is an essential part of the development process and will help you identify and fix issues as you build your game. Now that you know the basics of testing your scripts using the console, let's take it a step further. This time, we'll modify our script to actually interact with our game object. Instead of just logging messages to the console, we'll make the player game object move based on player input. We'll replace the update method with code that listens for keyboard inputs and moves the player accordingly. Open the player controller script in your code editor, and let's dive into the code and bring this functionality to life. We'll begin by removing all the previous scripts except for the update method. If you're following along, feel free to pause at any time if it's moving too quickly. We start by creating a public speed variable to control how fast our player moves, which can be adjusted in the Unity inspector. The update method is called once per frame. This is where we will place code that needs to be checked or updated constantly. Here we capture input using input.getAxis, horizontal for left and right, and vertical for up and down. These values range from -1 to +1, depending on the player's key presses. We can use the A and D to move left and right, or W and S to move up and down. Next, we create the movement variable to store a vector 3 that represents the direction and magnitude of movement. X-axis is controlled by move horizontal, and the Z-axis is controlled by move vertical. The Y-axis is set to 0 because we don't want vertical movement like jumping right now. We then multiply it by speed to adjust how fast the player moves, multiplied by time.delta time for smooth frame rate independent movement. The higher the speed value, the faster the player moves. Finally, we use transform.translate to apply the movement to the player in the world space. Our player should now move based on keyboard input. Let's save the script and test it out in Unity. Press the play button and use the arrow keys to move the player around. This looks good. We can now move the player object using the arrow keys or WASD keys. When the player object is selected, you'll notice the public variable we created in the inspector. Adjusting this value will change how fast the player moves. Try experimenting with different values to see how it affects the movement speed. One important thing to note is that any changes made to values in the inspector while in play mode will not be saved after you exit play mode. Be sure to make adjustments in edit mode if you want them to persist. I'll adjust the camera so we can get a better view of the game field. This will help us see more of the environment and keep track of the player's movement more easily. Let's make that change. We will now add a new component to our player, specifically a Rigidbody. A Rigidbody adds physics to the game object, allowing it to respond to gravity, collisions, and other physical interactions within the game world. To do this, select the player object, click Add Component in the inspector, and search for Rigidbody. Once added, you'll notice new settings appear, such as mass, drag, and gravity, which you can adjust to customize the physics behavior. Hit play to test this out. If we lift the player up during play mode, you'll notice that it falls back down. This happens because the Rigidbody makes the player respond to gravity. Since the ground has a collider and the player also has a collider, the player won't fall through the ground. However, if you move the player off the edge of the ground, it will fall into the void. Now, exit play mode and open the player controller script. Let's add the ability for our player to jump when we press the spacebar. First, we need a way to apply physics-based movement, so we'll create a Rigidbody reference. I'll declare a private variable called RB to store it. We also need to make sure the player is on the ground, so we'll add a private Boolean variable called isGrounded to track this state. Next, we'll add a public float called jumpForce to control how high the player jumps. This will be adjustable in the inspector, just like the speed variable. Now, in the start method, we'll assign the Rigidbody component to RB by calling getComponentRigidBody. This lets us apply physics forces to our player that have the Rigidbody attached. For the jumping logic, we'll use the update method. I'll add an if statement to check if the player presses the spacebar using input.getKeyDown keycode.space. To prevent infinite jumping, we check the isGrounded variable. When the conditions are met, we'll apply an upward force to the Rigidbody using rb.addForce. We multiply the upward direction vector 3.up by the jump force and use forceMode.impulse to apply an instant push. Finally, we'll handle the ground detection. I'll add two methods, onCollisionEnter and onCollisionExit. These are called whenever the player's collider touches or leaves another collider. These methods are built into Unity, just like the start and update methods, so Unity will automatically call them when a collision happens. There's no need to call them manually in our script. Inside onCollisionEnter, we check if the object the player collides with has the tag ground. If it does, we set isGrounded to true. Similarly, in onCollisionExit, we set it to false when the player leaves the ground. Now let's save the script and head back to Unity to set up the ground tag. Select your ground object, go to the inspector, and look for the tag dropdown. Add a new tag called ground, then assign it to the ground object. With this setup, the player can now jump only when grounded. Let's test this in play mode. Our player script works just as expected. The player can move around using the arrow keys or WASD, and it jumps when we press the spacebar. Thanks to the isGrounded check we implemented, the player can only jump when they're actually on the ground, preventing mid-air jumps. This gives us smooth and realistic movement for our player. Oops, it looks like our player fell over when we moved it. Let's fix that by freezing the rotation on the X and Z axes. This will prevent the player from tipping over while still allowing free movement and jumps. To do this, select the player game object in the Unity editor. In the Rigidbody component, look for the Constraints section. Expand it, and under Freeze Rotation, check the boxes for X and Z. Now, our player will stay upright while moving and jumping. Let's test it again. Let's also test and change the jump force variable in the inspector. Perfect. We've now explored scripting in Unity. We started with a basic script and learned how to test it using the console. We examined public variables, how they work in the inspector, and even added functionality to move our player using keyboard inputs. We then enhanced the script by adding jumping mechanics, utilizing Unity's Rigidbody and built-in collision methods like onCollisionEnter and onCollisionExit, ensuring the player could only jump when grounded. Finally, we resolved some physics issues, such as preventing the player from tipping over, by freezing rotation on specific axes in the Rigidbody component. With this, you've built a solid foundation for moving and controlling a player in Unity. You've learned how to combine components, physics, and scripting to create dynamic and interactive gameplay. Now, take some time to review what we've done. Experiment with the code, make changes, and see what happens. It's a great way to learn. This was a very quick introduction to scripting in Unity, and I hope it inspires you to explore further.